right, my Kenmore slash Whirlpool dryer is spinning, but it's not heating. So there's an element, a heating element, a coil inside the dryer that requires power to heat up and do the drying. So there's there's one of three reasons, as far as I know of, that would cause this problem. So I'm going to start with the first one, which is the fuse, and then there's a thing called a thermistor, which regulates the amount of power going to the coils, and then the coils themselves they might be broken and old. Okay, so I'm going to test that out first thing. And the reason this would happen, why it overheat, maybe my duct is clogged. I just cleaned this a year ago with a proper duct cleaning tool, but you never know. So first, safety: unplug your dryer. Then there are a number of, in my case, 7mm lag bolts keeping this back panel on the unit. This is quite an old unit, okay, so yours might be terribly different, but it's the same idea. And another tip would be I would take a video or a photo of anything to do with wiring. So we're going to talk about this in a second, but if you're going to be undoing, and this is really dirty, if you wind up taking all of this stuff out, you're going to have a whole mess of wires all over, and you'll be at a loss of where they go. So just take a picture before, and you could even be very pragmatic and take a piece of tape and write it on there, write numbers on there, and then when you photograph it in video, you know exactly where the wires go. All right, this is the back of my dryer. This is I don't think this has ever been opened up, so it's very dusty. If you can, I would take the opportunity to clean it out with a little hand vac. Some of this is it's really gunky, so you might need to use a wet cloth. The three things that are going to go wrong: there's either a fuse, and the fuse will blow if the unit becomes overheated. Okay, and that's a simple matter of extracting this with take the one lag nut out and then replace the little white unit. The second would be the thermostat, which is, I believe it's this one. I doubt that that's what it's going to be. The thermostat just reads temperature. And the third is the thermistor, which regulates the power going into the unit. So the big unit here is the coil. I'm not going to take it off because I'm hoping it's not the problem. But inside of this is, you can probably hear it. But there's a whole bunch of little woven wire coils, and those are what heat up, and that's what dries the clothing. And what you want to do for each of these, I guess there's the thermostat, the thermistor, and the fuse in this point, and also the coil. There are typically two wires attached to each. You want to pull one wire off, and that isolates the little part. Okay. And then down here we have the fuse. Okay, so each of these the parts that I'm going to talk about have 2 points, and if the points are connected with a conductor, then you will have what we call continuity. So I use a multimeter, commonly available everywhere. This is a very simple one, and it's set to ohms, which is testing continuity. So basically, it's going to just tell me if there's if electricity is able to flow between the 2 points. This is the fuse. So the fuse, inside the fuse is a little tiny thin wire, a filament, and if that fuse is broken, there will not be continuity between the 2 points. The 2 points are connected to the end of the fuse. So let me just get my alligator clip on here. I like alligator clips for this sort of thing because I'm using one hand, and then I'm just checking down here. So we have really strong continuity between those 2 points. So I'll undo the alligator clip. Yep, it goes to 0, and I'll reconnect it, and it goes back up to 100 plus ohms. Okay, so that fuse is absolutely working. I don't need to replace that. If I did need to replace it, I would just simply, it's a real easy thing, just one screw out, buy a replacement thermostat, pop it in. Okay, it's that easy. Back up to the thermostat. So again, I've pulled one of the leads off, and I've connected my alligator clip to one of the points, or one of the leads, and I'll show what happens when I touch the other clip, and we get continuity. So that means the thermostat is working. Okay, and again, if you got no continuity when doing this test, you'd simply unscrew this thermostat, replace it. It's real easy. All right, third point. This is the thermistor down here. So again, I pulled the neutral off, And I've got the one point connected to alligator clip, but I'll use the second point down here, and I'll just show my multimeter as I do this. And I'm showing continuity through the thermistor, so I know that the thermistor is good. If you had no continuity, you would want to simply pull this out and replace it. It's, again, quite simple. The last is the coil. So the coil is, again, just a bunch of elements that heat up. When electricity goes in through here, it heats up the coil. So both the points on the power point need to work. So I'll get this set up with a clip there, and then I touch it to the other point and read my multimeter, and I'm showing no continuity on that. So just to check, I'm gonna just touch my 2 points of the clip, and that's showing. So that means that there's the multimeter is working. So as I'm touching the other point here, there's no continuity. So I know that the whole, actually, unfortunately for me, too bad for me, it's expensive, more expensive than the fuse, etc. I'll have to uninstall this entire element and go purchase a replacement. All right, so there are a couple of screws that you just unplug. You can see down by my thumb. On the left, there's one there, and the other, and I pull the heating element out, and there it is. So if a heating element is damaged, that wire will simply be broken. So I'm going to quickly scan through and look for a broken wire. And okay, there. Let's see if I can get a good angle on this. But you see, there we are. If you look up in I'll move the camera over, right in the top right of the film, you see the broken wire up there. So that is my problem. So I need to replace this whole unit. And then just to make it more clear, I just physically pulled the coil apart, and you can see where it's broken. All right, just for interest, I'm testing continuity on the new one. There it is. That works great. So for sure, this coil absolutely is what the problem was. So now, just to, just for everybody's benefit, so the electricity, or the whatever that goes in here, connects back to this one, so it completes a whole circuit. So that's the, when you break this, the electricity isn't able to complete the circuit and nothing heats up. That's the issue. The new unit did not come with the thermistor, so just pop that off the old one, and one end, the end is connected to one of the points on the old coil. So just pry that off, and the thermistor will pop right out. And then just to double check, I'll connect the test I did before. This is the power point of the coil, and touching this, and we have continuity this time. This last time, if you recall, it was 0, right? So this should work now. And then one last check to make sure everything is connected again. I'll get the multimeter out there. So those two wires are connected. That wire's connected. Over here, those are all connected. Both wires back into the fuse. Both wires into the thermostat up on the top. You'll notice that I went through and cleaned all this out now. Just why not, right? So now it's all perfect again, all right? So I'll reassemble the back. What I will do, actually, I'll plug this in and try it before I put the back panel on. All right, it's definitely running, but it was running before, so I'm just going to make sure that the coil heats up. I can smell the coil or something, and definitely that coil is heating up. I can feel the heat. Okay, so I'm going to say this job is done. I'll put the panel back on and turn this up, and good luck, everybody.